Sorry. What I'm about to do today is to introduce you to some of our asynchronous philosophies, introduce you to some of the tools that we use, and how we can utilize those tools for a redundant system that is self-recoverable. And self-recovery is a huge key to asynchronous processes. Workflows are the obvious example of an asynchronous process. So let's take the example. I'm sure everybody has heard of Amazon. I don't know how often you've used Amazon in India or not, but we can use the example of ordering a book online. So you hit buy, and then a number of things need to come together. The credit card needs to be verified. The order needs to be put into the Amazon system. And then at some point later, a human being comes by and says, all right, this person wants this book. And then it goes through a workflow in which the book is found, the book is put in a box, the box is closed. The UPS or FedEx person or whatever shipping company they have, they ship it. So these are all workflow processes that are happening in such a manner that there is a time delay between any given step of the workflow. What that time delay is, I don't know. The time delay could be a year, or it could be a second, or it could be a millisecond. It depends on what the process is doing. Now, envision this. You click the buy button and the credit card is charged, but the system goes down. Well, what happens? Your book has not been delivered to you yet. So are you just going to be charged? Is there going to be a recovery? What if there's a legitimate bug in the system? How is that going to interact with your order? How can they recover off that? What if there are, a million books that are ordered all at the same time? Is the system capable of throttling different orders? Furthermore, what if there is 5,000 books and 3,000 videos? Well, maybe the book department can handle it, but the video department can't. So the throttling that takes place with the book department needs to be different than the throttling that takes place with the video department. I think most of you on the call know what WCF is and know that WCF has a throttling capability. You can set up a service and you can tell the service that it cannot process any more than N number of calls to that service. Well, that's great. It's a very valuable tool. However, it is not an intelligent tool. So it doesn't know. It can't say, I want to throttle 500 of these and only 300 of those. It's just one big hammer. Furthermore, it doesn't understand dependencies. Potentially, process B depends on process A. So there could be a throttle dependency that needs to take place. Well, WCF doesn't understand that. Microsoft has a workflow tool called Windows Workflow, which is a pretty good tool. It's a declarative tool. There is a GUI, and the idea is that you can drag on different processes into a model, and then you can write code behind those processes. The concept of asynchronicity is there. The concept of workflow, well, more than just the concept. I mean, it is a workflow system. But there is a lot lacking in that system. It does not throttle. It does not understand dependencies between workflows. It is not a high throughput scalable system, unfortunately. Payroll 1.0, which we are currently running, is built on top of Windows Workflow. Workflows are asynchronous and they are persistable, which is good, meaning that if you start a workflow, say for payroll, that workflow will be persisted in a database and has the capability to wake up at any period of time and to continue processing. And it does have the ability to go from one step to another. So it is a reasonable workflow system, but falls short in a lot of areas. We have built a system called Shi, S-H-I. You will hear that term over and over and over again. Shi was originally built because we had to deal with information amongst different systems. So the S stood for Salesforce, and the H stood for HSP, which was the name of the company at the time that Shi was built. And I stands for Intact. Intact is a third-party accounting system. And the idea was basically this. One of our salespeople in sales using Salesforce.com could hit a button and say, I just sold a product. Well, that kicked off a series of workflows that would happen over 3 different systems. It would send a REST protocol message to a site at HSP. And at HSP, we would start a workflow, what we call a Shi event. That event then had a series of steps that it needed to go through, depending on what the call to through the REST protocol was. I will give you an example. The Salesforce adds a new customer. So Salesforce will post a message to our system. Our system will then create a Shi event, and it might go back out to Salesforce and say, here's a key. You gave me key number 17. Now I want information about that customer. And Salesforce will return with a SOAP message that information. We might then input that information into our databases here at HSP/now Radius. We might do some processing, and we will then call the Intact system to do some work there. Intact might reply to us, and we might have to go back to Salesforce with Intact information. Now, as you can see in this one rather simplistic scenario, there are a lot of potential problems that can happen. Let me bring up a notepad.
John,
Yes.
just a second.
Yes.
The last sentences I couldn't hear, probably because of the network issue. Your voice was gone for almost 1 minute. The last sentence basically, when you said like the HSP creates a workflow, and after that, like it sends that to the accounting system. So from that, after that part, like it was not audible at all.
Okay, sure. All right, so let me back up. What I said was that, and I'm not sharing my screen yet, Ashok, thank you. What I said was that a Salesforce user, namely one of our salespeople, will be using Salesforce.com, and they will add a new customer. At that point in time, we have trained the Salesforce system to call the Radius system with just a very simple message that's posted through REST. And it might be as simple as System 3, meaning Salesforce to us, is posting an event, I don't know, 16, which is add customer, slash, here is the customer ID. So now I will share my screen and I will give you that. I'll attempt to give you a little bit of a graphical image of that. So here is salesforce.com, and salesperson adds a new customer. Salesforce.com will then post a call to Radius. So that might look like something like, I don't know. Sorry. I'm sorry. Can you give me 1 minute? I apologize. Sorry, guys. So it might post a call, something that looks like this. Radius.com / system equals 2, whatever the system 2 slash, actually be equals if it's rest. System 2 process or, event, which might be add customer, and alternate key equals 1, 2, 3, 4, 5. So Radius would accept the message, start what's called a shy event, which is a process, run a series of steps to fulfill the command. And that series of steps might be 1, obtain information from salesforce.com about the customer. 2, add information to the database in Radius. 3, call a web service on Intact to add the customer. 4, call a web service on Salesforce to tell Intact, to tell SF about information that Intact may have dictated. N. And that could go on and on and on for 25 steps or 2. Some of the workflows are extremely complex. And at that point, I'm getting a message from GoToMeeting telling me it might have lost audio. So, Hemant, can you still hear me?
Yes, John.
Okay, I will continue then. Now let's think of this. Let's think about a couple of the problems associated here. What if right after this, plug is pulled on our system? So just in case I'm speaking in American cultural terms, the plug being pulled is a fictitious description of somebody tripping over the server's plug in the server actually losing electricity and going down. The point is something happens here. What happens to this workflow? Well, unless it's persisted, then the workflow has stopped and all has lost. And we are left in a state of inconsistency. I'm sure everybody on the phone has an understanding of what an atomic transaction is. And basically in database speak, that's you know, a vehicle to ensure, I'm just making this definition off the top of my head, to ensure that all actions execute on none of them. Geez, having problems this morning. None of them do. So the quintessential example of that is taking money out of a bank. You know, you go to the machine and you say, I want 100, in my case, dollars. And the machine gives you the cash. And after it gives you the cash, the plug is pulled, and the money is never removed from my account, or vice versa. Well, a transaction, wrapping that in a transaction ensures that. And of course, we have that on SQL Server. That's called an atomic transaction. What most of you may not know, I don't want to make any assumptions, is the idea of an idempotent transaction. Now, this is a very, very, very big deal. And if you're not familiar with idempotency or idempotent transactions, please do a little research. It basically says that no matter what system I'm on, if I'm using different systems, no matter what the circumstance, the transaction will be safe. So in the case of SQL Server, that's easy because SQL Server has the concept of a transaction, and it controls the transaction. But even in SQL Server, think about what happens if you have to commit a transaction over multiple servers, over multiple databases. Then you need what's known in the database world as a two-phase commit. Two-phase commits get very expensive in terms of locks and communications among systems. In the Microsoft world, two-phase commits are executed via the MSDTC, which is the Microsoft Distributed Transaction Coordinator. And that executes what's known as the two-phase commit protocol. And that allows atomic transactions to take place over any resource that subscribes to MSDTC. It is very slow, very, very slow. It takes up a huge amount of resources. And it is only specific to resources that subscribe to the two-phase commit protocol. Idempotent transactions work in a very different way, and any system can take part in an idempotent transaction because it is more a pattern than a physical piece of software. It is a pattern than an intelligent piece of software that knows how to control systems. Let me give you a very simple example. Let's go back to our Amazon. And let's click the button, the fictitious button of buy a book. Well, what happens if you click the button twice in succession? Very quickly. Let's say the piece of JavaScript that's supposed to run to disable the button doesn't work, and now you have, clicked on the button twice. Are you going to get two books the same order? And it says my connection has been lost and then restored, so hopefully you can still hear me. Can you still hear me, Hemant? Kushi, can you guys hear me?
Yeah.
Okay.
Yeah, John, I can hear you.
Great. Because GoToMeeting is just giving me warning, so I don't know when you guys can hear me and when you can't. Just adds the difficulty here. So, as I was saying, that what happens when you click that button twice in succession, and you're going to get 2 books? And the answer is no. Why is that no? It's because Amazon runs idempotent transactions. It has the ability to understand that the person clicked the button twice or 1,000 times and will not execute its workflow more than once. How does it do it? Well, I don't know. In the case of Amazon, I'm guessing it sends some type of session identifier or some kind of unique key that says, I want to buy this book, and here is my key. 45678 is my key. Well, if they get another request to buy the same book with the same key, they know something has happened and they don't allow it. So it can be said that that transaction is idempotent. It promotes the idea of eventual consistency. Eventual consistent. That's wrong. Consistency. That looks wrong too. But I think you guys know what I'm trying to get across. Eventual consistency is a concept that is at the center of idempotent transactions. Atomic transactions are immediate consistency. So as soon as the transaction is executed, the database is or the data stores or the resources are in a state of consistency across all data stores. That is not true with idempotent transactions. Idempotent transactions say the state of the data will be eventually consistent in 10 minutes, 100 minutes, 10 years, or 2 centuries. It will be eventually consistent. Now, if the idea of idempotent transactions is new to you, your first reaction is going to be, what? No way. Can't happen. Well, it just so goes that the world works on idempotent transactions, not atomic. There's no atomic transactions in the cloud. They don't exist. You may have or may not have seen this in India. I don't know. But if you look at your bank statement, and I don't know how big electronic banking is in India, but if you look at a bank statement, or you look at your credit card, it might have the concept of a pending transaction. Why is a transaction pending? Well, it's pending because of the idea of idempotent transactions. It's going to say, okay, you've made a charge, and I on the other side, I as the credit card, I am going to mark this money as unusable for the moment. I'm actually not going to commit, but I'm going to say that money is marked as unusable. So I'm holding that money. And then something else happens maybe with the other system. You can't use that money, but the money has not been paid to the other system yet until there is further handshakes and the other system says, okay, I'm ready. And then the bank says, yep, I'm ready. And then that pending transaction becomes a real transaction and the company has been paid, and the state of the transaction goes from pending to just any other transaction that has been decremented from your bank account. That's idempotent transactions at work, because they need that because it goes across multiple systems. Okay, I'm going to move on. You should probably look into idempotent transactions if you're not familiar. So let's get back to Shi. Shi gives us the ability to encompass the concept of workflows, encompass the concept of dependencies within workflows, but also dependencies between workflows. So I don't even want a workflow to begin yet if there is another workflow that is executing. I must wait. For one reason or another, I must wait. It encompasses the capability that enterprise service buses, let me back up on that statement. The concept of an enterprise service bus, and you should probably look it up, Google it, you'll get many different answers, is an interesting concept. An enterprise service bus really doesn't have a solid definition of what it is. Vendors have their own definitions. But that being said, our Shi system certainly displays a lot of the features that you would expect out of an enterprise service bus. So in a way, I could call it an enterprise service bus as well as a workflow system. I'm going to show you something now that puts this in a little bit more light here. And what I'm going to show you is going to look confusing in the beginning, but let's see. So what this is, and you'll hear this word a lot, is a piece of software called the Poker Manager. And what the Poker Manager is, it's our enterprise service bus. And it is all intelligent about all of the workflows that are happening all over the company. This list here is on the QA box, one of the QA boxes. So we can see that, for example, the top line here, ID 191,439. The next wake-up time for this process is 8:11 at 10:15. And then there's some state information. And then the last column is command type start payroll calendar. So the developer has said that I am creating a command called the start payroll calendar. And the start payroll calendar has a number of different steps. And the Poker Manager is the guy that's in charge. He's the traffic cop. He's the policeman that says, okay, you told me that you want to wake up at 10:15, so I'm going to wake you up at 10:15. Other things that the Poker Manager might do is, so naturally, sometimes processes fail. Well, you can see in red here, 203130, that is a process that is in needs repair. For some reason or another, while that process was running, it failed. Why? Could have been because of an exception. A plug was pulled. A database connection problem. A network connection problem. Who knows? The developer has the ability to tell the system during declaration of the command that if you feel I want you to wait 30 seconds, let's say, or 1 minute, and then I want you to try again. And if that fails, I want you to do the same thing after a minute, after 2, after 4, and do it 20 times. And if it fails still after 20 times, I want you to put the workflow in a state of needs repair and email me that there is a problem. So think about that for a second. Think of the power of what that does. Self-recoverable workflows. Most of the time, it will recover without intervention from the developer. Think of a deadlock in a SQL Server scenario. If some process is saying, get me a dog. Well, SQL Server says, or update a dog, let's say. And SQL Server, two people try to update the same dog, and SQL Server can't resolve it, so it chooses one to be the victim, and you are deadlocked or you are locked. And in the case of a victim, you get an exception. Well, without the poker manager, that process fails and nobody knows about it, and just life goes on. But the poker manager is watching. He says, okay, I told this guy to do something, and he hasn't done it. So I'm going to put him in a state of failure. And then he looks at the command, the declaration of the command. He says, oh, okay. The command says you want to wake up in 1 minute and try again. So poker manager will execute that same process in 1 minute, and chances are the deadlock has passed, the lock on the resource has passed, and the process executes. So there's a variety of reasons why a process might fail. But Poker Manager is there to save the day. And only after n number of failures, or n time period has passed, will Poker Manager finally say, look, I don't know. Sounds like you got a serious bug. I need to email you, and you need to do something about it. I don't know how many workflows we run a day, but it might average in the thousands, certainly the hundreds. And Poker Manager is there to catch all of the problems. If you look further down the screen in purple, 210575, this status of this workflow is under research. So what happened is the developer, in this case RG, Roxana, was emailed of a problem. Now Payroll 2.0 is still in development, or it's actually code complete and feature complete, and QA is testing, and we are fixing bugs. But Roxana got an email and said, oh, okay, this thing failed and I need to research it. So it goes into under research, and at some point she will tell the Poker Manager to repair. And now just let me go to the menu here. Let me go back to the menu. So this is going to be turned into a web application at some point. But she might say 8, repair. So let's just do that on 214311. And it's QA, so I don't feel bad about it. Let's see. First of all, I want to stop this from scrolling. Let's see. Clear region update. Turn off monitor messages 11. Okay. And then let's repair 8. 214311. Whoops. 214311. Okay, now let's look at what's happening. And I can see that Poker Manager has resumed this process. And let's check it again. So it's most likely processing. This guy here is called, if we can see the title, number of heartbeats. So what's going on with the number of heartbeats is the employee upsert process, it was resumed, and it will say, okay, here's a heartbeat. And so Poker Manager knows the thing is alive. And every n seconds, employee upsert will send out a heartbeat. And therefore Poker Manager say, okay, this guy's working. If he stops hearing a heartbeat after so many seconds, he feels the workflow. Okay, something went wrong. and he goes into failure and he will try again. And there's all kinds of mechanisms that will prevent a process, two machines running the same process. Remember the concept of idempotency. So in the employee upsert process knows how to be idempotent. So there's no danger of running the same thing twice, of taking money out of the bank twice for the same transaction, or ordering the book, because it's idempotent. And idempotent is promoted at the highest level and the lowest level. So Poker Manager itself is idempotent and will protect against all kinds of problems. Depending on the way the process was written, the employee upsert might have to protect itself as well. We try to stay away from that, but it's possible. Okay, so let's just see where that goes. So, oh look, it went into repair. Interesting. So that means somebody got a email. I don't know if I'm on that email list. Let me look. If I'm on that email list, where's my email? Did I go away? What is this guy? Oh, that's another VM. Poker report, workflow field. Okay, this is not the email. This is on QA2, but you can probably get the idea. So it shows me the Shi event. And this was, by happenstance, a employee insert. And it shows me what the current step was. So in this case, something called Swift code and IBAN number validator. It happens to be some bank process, a bank number. So that's the current step. It only went through one retry because the developer said only try it once. Here's the workflow history. And it says, oh, an exception encountered during the invocation of a workflow. Here is the exception. It gives the full exception. It also will take us through what has been happening. So at this time, that step was completed, prevent duplicate workflows, and blah, 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 blah. And I can see exactly what's been happening with this workflow. And then this is an audit trail, so more information. If I wanted to, I could repair this. So remember when I went into repair for my Poker Manager, I could click that and then the Poker Manager will repair it. Or I could put this under research. Now, I could also take this query, what I've named the magic query, and let me go to a SQL Server and let's say use Shi. Now what I need to do, this was within QA2, so let me change the connection to, that is on DevBoss SQL 1, connect, use Shi QA2 environment, and there's my magic query. So it seems like the SQL Server is slow, but it will, here we go. So it will give me that information in SQL Server that we just saw in the email. Okay. So what I hope that we're starting to see is that we can write processes that are idempotent, that are self-recoverable, that are self-reportable, that scales like crazy, that can be throttled, because somebody might be saying, you know, there was 1,000 employee upserts all at once. And we say, you know what? We don't want our system, and when I say our system, just the Radius computers in general and all the software. We don't want 1,000 of these workflows being run at the same time. Why? Because we don't believe it's important enough to get all that work done at once. Now, here's Here's an important piece of information. Think about the intelligence of the poker manager. You can say that I want no more than 50 employee upserts running at once. But you can run 200 of those types of commands. 200 send data for payroll periods. Well, why 200 of those? Well, maybe we put a higher priority on payroll. Or maybe we know that send data for payroll period is just doesn't tax the system very much at all. So we say, well, 500 of those is good. So we can now start to prioritize not a particular workflow, not workflows within payroll, but workflows in general. We can prioritize the whole damn company based on the intelligence of what the poker manager knows. That is so powerful. Furthermore, I haven't done this yet, but it will be the next step, is to start to look at the heuristics of the individual computers and say, you know what, geez, every night around 10 o'clock to 12 o'clock, there seems to be a pretty low utilization. So let me increase the number of workflows can run at that time, but then decrease the number of workflows that might run at 9 p.m. or 9 a.m. So we can really start to throttle. And I hope if you know WCF that, the throttling WCF is good, but it doesn't touch the capabilities of this enterprise service bus that we've built. That was a mouthful. And obviously I didn't show any code for reasons we're not there yet. However, remember my philosophy of what I want human beings to do. I don't want them to do things that machine code can do or generated code can do. So it ends up writing a workflow step is just ridiculously simple. It's frameworks understands things, and you will execute some operation in some service someplace, and you will just write the code for that one small idempotent process. And there you go. Now you have one small step within a command, and one command is a small a small unit of work within the enterprises, within that domain's work, and that domain within the enterprise's work. So you could probably see how we start to scale. And of course, I believe we're going to the cloud, so we'll have ultimate scalability, but maybe we won't want to pay for that scalability. So this is where the poker manager can control actual costs in the cloud, because it will know I don't need to scale employee upserts. It doesn't have to happen in 1 second. It can happen overnight. So I'll find the best spot for it to execute instead of spinning up another service in the cloud fabric. Okay, that's an introduction to Shi. So I'll open the floor up for any questions that anybody might have at this point.
So, John,
Yes, I'm here. Go ahead.
yeah, John. So for this ESB, like how about for like the scheduled jobs? So do we still use the ESB, or that is going to be handled in a
So
different?
jobs are scheduled when somebody creates a command. So I'll just give you a quick look at what here. Let me pick up back so if I am to look at my database and I say select star from command type. Well, first let me back up. Select star from system type. So the first thing to know is that Shi understands different internal and external systems. So within that, now I can say select star from command type. And command type, here's an example test here, create dog, command type 102. Command type 102 will have certain, like star from workflow, no, command type, workflow, step type. So this thing runs in sequence, certain commands where command type ID equals 102. So this is the first sequence, the second item, the third item, the fourth item, the fifth item was left out. Then you could see workflow step types. Well, what does that mean? Select star from workflow step type where ID in 1, 2, 3, 4, 21. And now we can see that here is the individual workflow steps that this command will run. If I go back to commands, and I'll now answer your question, select star from command type where ID equals 102. So by the way, here's something called maintain key group. And here's the contract. And that service is in HSP Shi workflow utility, workflow processing, maintain key group. So I can go and see the code if I want. And the maximum amount of processing seconds is 60. And the maximum time to fix is 86,400. So if I can't fix it in that time, then I want to retry. How many times do I want to retry? One. I want to retry, 30 seconds from each other. If I look at the command, it will have further controls of things like maximum instances. Well, in this case, I only want one. Zero means unlimited. I only want to try once, retry. I want to have the maximum retries. Seconds to wait until you think something's wrong, 300. So the poker manager will understand all of that type of information because during the creation of this command, Ashok, the developer, through the requirements, has determined that, certain things about this command. So it's the declaration of these items are built into the database. I don't know if that addressed your, I have no idea if that addressed your question.
Okay, I got a general idea of this, but there is another requirement, or maybe we'll have a separate discussion on that. Something related to reports, a new requirement. I thought, okay, will Shi help me there?
Sure. Yeah. So the answer is yes. So here's the story, right? Reports in general can run synchronously or async. And the reporting mechanism was built like that. So if it's a long-running report, it's going to take a lot of resources. It should be probably async. Now, I don't know if any of the reports actually execute on an asynchronous basis, but it's something to consider. You will all become very familiar with Shi. This I can promise. It is the hub of everything we do. Kushi and QA, you will understand Shi very well shortly. Developers, you will know it intimately. It is just simply stated, it is the most important pattern, and the Poker Manager is the most important piece of software we have. Along with security and such, of course, not to downgrade the importance of security. But the Poker Manager is absolutely crucial and central to everything we do. Anybody else?
Yes, Lakshmi.
John.
Okay.
John, I have to jump into another meeting. So
Okay. Okay. See you later.
Yeah. Thank you, John. Yeah. Bye.
Go ahead, Lakshmi.
John, how many workflows we have created for our system?
I would probably say, well, let's just look at the number of command types here. There is there is 123 command types. There are 120 workflow step types. So a command type can reuse other workflow step types. So that gives you a combination of this. Select count. It's a many-to-many relationship. A lot of processes are reused.
So basically, yeah, we have only one workflow, but in that workflow, we have created different stages, right?
Well, no. So a workflow is an instance of a command type. So let's go back to command types again, right? So let's just look at something. Okay, so here is a workflow called employee upsert. Now, employee upsert will run hundreds or thousands of times a day. So a workflow is an instance of a command type. So whenever an employee is updated in the system, it will kick off a employee upsert workflow. And that happens constantly. So instances of workflows, thousands and thousands and thousands per day. But the definition of command types, there's 102, we said, and 120 workflow step types.
Okay. So, Poker Manager is the watcher for each command type, right? Each stage.
Poker Manager is the intelligent piece of software that is call it the traffic cop, that understands when to start, when to wake up, when to throttle. It is the piece of software that's controlling all of this orchestration.
Okay. Okay. See, here you said Shi is a system, right? Shi is a system, right? I mean, Shi is a system means is a service or system means.
I don't know what you mean. Shi is a system. I guess you could classify it as a system, sure.
Based on my understanding, yeah, actually, based on my understanding, Shi is a service which is accessing three different services. Third-party services.
I get what you're saying. Okay, what is Shi? That's actually a great question. Shi is a concept. That's what it is. It's a concept.
Okay.
It encompasses the Poker Manager. It encompasses workflows, but it was an early name that I put to a system that specifically dealt with, Salesforce, HSP, and Intact. At the time of the naming, it was very limited in scope. I actually, during that time, I used to say this, Shin, because Shi N, because it could have any number of external systems or external processes. So Shi is really a concept for an enterprise service bus coupled with a workflow system that is redundant and recoverable. That's really what Shi is. It's more of a concept.
Okay. So this is Shi is the concept for accessing third-party systems, right?
Yeah, the answer is yes, but not only that, it accesses internal systems and runs workflows.
Yes, yeah, right. Yeah. Okay. Okay, thank you, John.
Sure.
Yeah. Yeah.
John,
Yeah.
I have a question, and that is like when we talk about Shi, Shi is mostly to have a common in it's like an it it will be used for interaction between various different systems. It's a channel for interaction.
It's a channel
Okay.
for interaction, but not only systems, but processes. So processes could be taking place on our system or other systems. So here's a process, right? Process 1, add 2 numbers. Process 2, take the sum of process 1 and divide by 2. Process 3, terminate the workflow. That's a simple Shi process. This is an operation call or a workflow step type. This is a workflow step. This is a workflow step. And this is a workflow step. Now, a command type, let's say I'm going to name this, example. And the example command type says execute process 1, then process 2, then process 3. So that's a command type that executes individual workflow steps. Now, this process, could take place anywhere. It could even be in the extreme situation, a manual process. And in fact, in the case of payroll, one of the processes might say enter data, and then we sit there and we wait for the data to be entered. But it is the Poker Manager piece of software, the Enterprise Service Bus, that is coordinating all of this. The Poker Manager knows that, okay, process 1 told me it's done, and then, should I delay or should I wake up right away? Most time, wake up right away and run process 2. Oh, but before I run process 2, do I have any other process 2s that are running? And if I do, should I throttle that back? No, I don't. Or yeah, I do. I have 50 and I can execute up to 60, so I'm okay. Oh, but wait, do I have any other dependent processes that I have to wait for? So it's executing the series of algorithms that's helping it determine what process to wake up and when. Did that answer your question at all?
Yep, and very nicely. Thank you.
Welcome. Anything else for now? I'm sure you'll have a lot of questions.
John.
Yep.
John. Yeah, John. John, I have one more question.
Just a second, Lakshmi. Just a second. John, I might have to take your leave because I have to jump into another call.
Okay.
Javed is waiting.
Great.
Yeah.
We'll talk to you later.
Talk to you later.
Thanks.
Thank you so much for the session. Yeah.
Sure. Go ahead, Lakshmi.
John, our workflow is sequential workflow or some state machine, another kind of workflow is also there, right? Sequential or state machine workflow?
It's yes. So it's a good question. So any process can be a state machine unto itself. The workflow works in terms of it's sequential. But
it won't.
any process can say skip me or run a different process. So I mean, you can have a graph. It's flexible. You can do what you need to do. Typically, the poker manager understands sequential processes, though.
Okay. Uh-huh.
And I am noticing
So if
Lakshmi, sorry, I'm noticing
yeah,
the time.
yeah,
I'm late for a meeting too, so we're gonna have to pick this up later. Okay?
yeah, sure. Thank you, John.
Thank
Yep.
you, and thank you.
Yeah. Yeah.
Thank you. Bye.
Thank you. Yeah. Bye.